Use an inverse trigonometric function to write theta as a function of x. The diagram to the right of your screen, where we have the right triangle, theta is marked in the lower left vertex. We have an adjacent side length of 6 and a hypotenuse of x. This stuff here, I don't know how it got on there from class, but anyway, just ignore this part. Back to the diagram. With respect to theta, 6 is adjacent, x is hypotenuse. The trig function that uses adjacent and hypotenuse is cosine. So based on our diagram, we can write cosine of theta is equal to 6 over x. Now, since we're asked to write theta as a function of x, we take the cosine inverse of both sides. Cosine inverse of cosine cancels, leaving theta, and that's equal to cosine inverse of 6 over x. Basically, what this function does is it lets us change x on that hypotenuse to any length. I'm going to mark through this. It's bugging me, sorry. And so depending on what the value of x is, the angle will change. The example underneath, use a right triangle and your knowledge of inverse trig functions to find the exact value. And we're going to have a composition in this problem. We have sine of cosine inverse 3/5. When you have a composition, start on the inside. I call this theta. Over to the right in the purple color, theta is equal to that inverse cosine of 3/5. If you take the cosine of both sides, you get cosine theta equals 3/5. And that allows us to come to the right triangle, mark one of the vertices with theta, and with respect to where that's located, we have adjacent and hypotenuse. This opposite side we can find through Pythagorean theorem. We know that 5 squared has to equal 3 squared plus that side squared. So x squared, when you solve for it, we have 25 equals x squared plus 9. Subtract 9 from both sides. X squared equals 16 when x is 4. So we've got the opposite length of 4. Back to the main problem, we were taking sine of this angle. So we have sine of theta. And from where theta is in our triangle, we have opposite over hypotenuse for a value of 4/5. That's Use a right triangle and your knowledge of inverse trig functions to find the exact value of this one. With this one, we have tangent of sine inverse 3x. Inside, because this is a composition, we start here. Theta is equal to sine inverse of 3x. You can create a fraction by putting 3x over 1. Take the sine of both sides. Sine theta is equal to 3x over 1. In your right triangle, mark one of your vertices with theta. Sine is opposite over hypotenuse. The Pythagorean theorem will let you get the length of the third side. Well, with respect to theta, this side is adjacent. So we know that 3x squared plus this adjacent side squared has to equal 1 squared. And that's this opening line of the equation, Pythagorean theorem. 3x times 3x is 9x squared, plus the adjacent side squared. 1 squared is 1. Subtracting 9x squared from both sides, and then take the square root. Adjacent will be the square root of 1 minus 9x squared. Now that we have the triangle complete, go back to the top left of your screen, and we'll take tangent of that angle. From this angle, tangent is opposite. This radical term is adjacent. So 3x over square root of 1 minus 9x squared is your final answer. Now let's switch gears and go back into some familiar territory where we solve for right triangles. If you're asked to solve for a triangle, then you have to find the amount of each angle, the angle measurement of each angle, and the length of all three sides. Now, you'll have to be given a little bit of information to get it started, but let's take right triangle ABC. I always put C for my 90-degree angle. It is up to you where you put your A and B. Um, Wherever you do label them, though, capital letters represent the vertices or the angles. Lowercase represents the opposite side length. So capital B, angle B is 35 degrees. Side B, because that's lowercase, will be the length of the side opposite. That's where the 8 goes. Angle A, we can get it because 35 and 90, whatever the difference between those and 180 will get us angle A. So 180 degrees minus the two angles that we know, 35 and 90, leave us a remainder of 55 degrees. So that's what angle A has to be. Okay, so at this point, we know all three angles. B was 35 degrees, that was given. C is automatically 90 because of the right triangle and the shape of it. And then the difference between those two and 180 was 55. At this point, all we know is side B. Side A, and I'm going to pick on angle A. Tangent of angle A is A over 8. Since angle A is 55 degrees, tangent of 55 degrees has to be A over 8. And that's how you set this ratio up. From the 55-degree angle, tangent is opposite over adjacent. If you multiply both sides by 8, 8 times 10, 55 degrees, make sure your calculator's in degree mode, you will get approximately 11.43 as the length of A. Now, if you know A and B, you can use Pythagorean theorem to get C, or you can just use another trig ratio. For example, in class, we decided to use sine, and we also picked this 35-degree angle. So sine of 35 is the opposite over the hypotenuse. Opposite hypotenuse. Multiply both sides by C, and you get C times the sine of 35 degrees equals 8. Divide both sides by sine 35. C is equal to 8 divided by sine of 35 degrees, which also comes out to the same value as if you were to use Pythagorean theorem. So you have more than one way to do them. This is just one way, and we decided in class to set it up with a trig ratio. Solving another right triangle, we are given side A is 38 and side C is 39. These are both lowercase letters, so those represent side lengths. Again, draw a right triangle. I usually stick with C as my right angle. A and B, you can label those either way, but be very mindful that wherever you label your angle, the lowercase letter of it is opposite. So if you put capital A in this bottom right vertex, side A will be here, opposite of it. Side C was 39. Now, since 38 and 39 are not rounded numbers, they're pretty good to use. You won't lose any accuracy due to rounding. B squared, which is opposite of angle B, side B squared plus 38 squared has to equal 39 squared. So in the green ink, I've set this up with Pythagorean theorem. Subtract 38 squared from both sides and take the square root, and you'll find the length of side B to be square root of 77, which is an exact number, but if you had to approximate it, it'll be 8.77. Now, we know all three sides. We just got to come up with some angles. In class, y'all decided to find angle A first. I recommended using sine of angle A because opposite and hypotenuse have no rounding. Those were the original given numbers. So sine of A is equal to 38 over 39. And in the navy ink here, that's what we're solving for. From angle A, sine is opposite over hypotenuse. Solving for angle A, you take the sine inverse of that fraction, and you get approximately 77 degrees. 90 and 77 degrees, those add up and only leave us room for 13 more degrees. So angle B has to be 13 degrees. Find the altitude of the isosceles triangle where theta is 25 degrees and B equals 14. In WebAssign, this diagram to the right is the one you'll be given. You'll be given a triangle with two angles identical, and then you are given the length of the base. The altitude is how tall the triangle is from that top vertex straight down to the base. I did little highlight marks here because over here to your left in the diagram, that base of 14 has been cut in half. I used A for altitude and 25 degrees was given. To find A using the given angle 25, that's opposite and 7 is adjacent, so tangent is the perfect trig ratio. Tangent of our angle is equal to opposite over adjacent. Tan 25 degrees is equal to A over 7. Multiply both sides by 7, and you get A equals 7 times tangent of 25 degrees, or approximately 3.26. The sun is 25 degrees above the horizon. Find the length of the shadow cast by a building that's 100 feet tall. Round your answer to 2 decimal places. Since we're finding the length of the shadow, I highlighted it in class with this little orange segment for the length. The building is 100 feet tall, and the angle of elevation is 25 degrees to the sun. We're asked to find the length of the shadow, so we're looking for this x. With respect to 25 degrees in our building and the shadow, we have the building is opposite, the shadow is adjacent, so tangent is the wise choice. Tangent of our angle, 25 degrees, is equal to the length opposite of it over the length adjacent to it. Multiply both sides by x, and you get x times tangent of 25 degrees equals 100. Divide both sides by tangent of 25 degrees. This is your exact length. What your calculator gives you is the approximate length, so it's just shy of 214 and a half feet. Since we're asked around the 2 decimal points, 214.45 feet is the approximate length of the shadow. I hope this video helps. I apologize for that little computer glitch on the first slide. I'm still not sure how that got there, but anyway, I hope the rest of the video was helpful for you. And if you need any help, reach out by phone or email. Swing by the office if you're on campus.